number of turtles. Currently, if we remember in the code, we hard-coded 100 turtles to be created in setup. But what we could do, and what we will do, is we could create a slider which will set a global variable, and we could use that to set the number of turtles. So I'll just place a slider here. I'll call it population size, and well, actually I'll call that variable pop size, make it easier to remember. I'll make the minimum 1 because we don't really, there's no point having 0 turtles. The increment should be 1, and I'll make the maximum 1000, so we could have between 1 and 1000, and we move in increments of 1. So I'll click on OK. So what have we done here? Well, what have we done? We've created a global variable which is set on the interface called pop size, that we can set by dragging this slider. Now we need to change the code to reflect that, so we can replace the 100 here by the global variable pop size. So we could test that out. If I go back to the interface screen, I can set it to 1. Let me put it to the minimum. So set the pop size to 1, setup. Yes, now we have a single turtle. I could go to the other extreme, 1000. That's quite a crowded environment. It'll be interesting to run this and see what happens. Very crowded. Okay, so now we can vary the population size with a slider. Let's modify the program, the go procedure in the program, to do something a little bit more interesting. Instead of when a turtle finds itself in an occupied patch, the turtle jumping away in a random direction, let's actually ask the turtle to die. So if I delete these commands and simply replace the commands with die, which is a primitive which, as its name suggests, causes the turtle executing it to immediately cease to exist, we can see how that affects things. So I think we can probably intuitively see what's going to happen here. Let me set up again. We've got 128 here. Let me make it a bit busier than that. 460 perhaps. Set up and go. So obviously what's happening now is when a turtle finds itself sharing a patch with another, it simply dies. So over time there are going to be less and less turtles, obviously. Depending on the directions they're pointing in, I guess that eventually there might just be one turtle, although several could coexist if they were moving in parallel lines, but that's another issue. So now it would be interesting to modify the code again to get some more interesting dynamics, but just as an example of how we might modify the code, let's allow turtles not only to die and move, but new turtles to be born. Allow turtles to give birth, if you like. So first of all, what I want to do is create a slider which is just sets a probability between 0 and 1, and we're going to call this probability birth prob, and that will be a fixed probability, and under that probability turtles will give birth in each cycle. So first of all I'll add a slider, and so this is a real value we want now. I'm going to call this global variable birth prob. I'm going to make the minimum 0. I'm going to make the maximum 1, since this is a probability. I need to make the increment smaller, so I'm going to make the increment 0.01. maybe I should set this to 0.1 as the default value. So now we have another slider that sets a global variable called birthProb, and it varies between 1, 0 and 1. Okay, so now we should modify the program to make turtles give birth with this probability. How do we do this? Well, an easy way to do this is to have another ask command to all the turtles after the movement and die phase. And we can simply say if prob birth prob hatch 1 set heading random 360 forward 1. So let me explain this. I'm asking all the turtles that if the birth probability with probability birth probability to execute these commands, and the command is hatch1, which is a primitive which tells the current turtle to produce a clone of itself, to hatch, to give birth to a clone of itself. What that means is it creates a copy that inherits all the turtle values associated with the current turtle that executes a hatch command. It's like a create command, except you're creating a clone of the current turtle. And the commands that we place after this in square brackets allow us to set some specific values for that particular hatched turtle. In this case, I've set the heading here to a random direction and moved that newly hatched turtle forward 1 patch, and the reasoning there is that we don't want the clone to stay on the same patch, since the chances are this will lead to either the parent or the offspring dying in the next round, since they'll be in the same patch. There's another procedure to define here which I need to do. The prob command, as you see, is not a primitive since it's not highlighted in blue, and I'm going to write this, and the reason I've included this here is just to give you an idea of how you create reporter procedures, that is, procedures that return some value, often called functions in other programming languages. And we do this in this way. It's similar to defining any procedure, but we use the special command to report. In this case, I've called the procedure prob, and then we follow that definition with square brackets and a parameter. In this case, I'm going to call that parameter x. Oops, I'll put an end there. So what this means is the value that follows the prob, which in this case is birth prob, gets passed as an argument to this prob reporter procedure, and it's assigned to the local variable in this procedure called x. So x would now be set to birth prob. Since birth prob is a global variable, this is not really necessary, but this is just as an example of how you might write a simple reporter procedure. So how would we actually return a value? Well, we want to return, in this case, a true Boolean value if the value that's passed in is true with probability x. So we can do that by typing report, which is just the command that tells you to send back as the value produced by this procedure the value that follows. And in this case, we could achieve our desired function by using random float 1 less than x. So this is a rather simple procedure. What does this do? It reports true with probability x. It does this by using the primitive random float followed by 1, which simply produces a floating point number between 0 and 1, effectively. So, but never between 0 and up to 1, but never equal to 1. So long as x is greater than this, this will return true. So therefore, if x was in fact 1, this would always return true. Probability of 1. If x was 0, this would always return false. This condition would always be false if x was 0. This condition would always be true if x was 1. And obviously 0.5, it would be true half of the time, since this returns a pseudo-random number, which is different each time. Okay, so we should be able to run this now, and if we set different probabilities for our birth prob slider, this will produce different kinds of birth rates. Let's see. So let me set up again, and currently let me make the probability quite low. Yeah, even, well, maybe 0.1. So that would mean every 10 times on average a turtle takes an action, it will actually give birth or hatch a new turtle. So it's hard to see, so let me reduce the number of the pop size. In fact, let me reduce the pop size to 1, which allows us to see more clearly the birth process. So actually, interestingly, you can see that quite rapidly you get quite a lot of turtles, and then eventually it kind of settles down, because there of course is a limit to how many turtles can be produced, because as they bump into each other they die. It's interesting actually, we could, if we wanted to track the growth of this population size, we could add a plot which showed the number of turtles in the environment. So an easy way to do that is to select plot, and then we'll click on a blank area, and I'm going to call this plot population size. And in fact, if you look, at least on my version of NetLogo here, the default command in the pen update commands line here is plot count turtles. You can type anything in here, it just happens to have already included this as a default. Whether all versions of NetLogo do this or not, I don't know. So if I actually click OK, I can leave everything else at default. I'll just make this a little bit bigger. I'll click setup again, and I'll click go. And so all we're seeing now is a sort of a time series of population size by ticks, that we can see this growth here. I could speed this up a bit. So it seems to be hovering around 100, which is interesting. Okay, let me stop that. Of course, we can also add a monitor which just gives us the instantaneous value of the population, which is always interesting. If I set monitor and add here, I can now type count turtles, the display name of the monitor, pop size perhaps, So what we see now, if I start this again, this is just giving us the instantaneous value in time as opposed to a time series. Might make it easier to see where it stabilizes. Yeah, it seems to oscillate between about 90 and 100. Okay, so what we've seen here is how to add a plot output, a simple plot output, and a numerical output to the interface. And also what we've seen in a very simple way is how to produce a reporter procedure that takes one input in this case and returns one value, which is a true or false value in this case.